Video time. Number 1. If you see these bars here, this means absolute value. And if you forgot about absolute value always refers to a distance. So think of it as the distance from 0. If we said the absolute value of 4, that's 4 spaces away from 0. If we had the absolute value of -4, that is still 4 spaces away from 0. So absolute value is a distance, which means we're going to have 2 possible answers because it can be a positive or negative possibly on the inside there. So the first thing we need to do is isolate my absolute value portion. So in order to isolate the absolute value, we need to get rid of this 2 first. We don't want it on this side. So what we're going to have to do is divide both sides by 2. And that leads us to, I'm going to write it over here. We're going to have z plus 3 absolute value less than or equal to 12 because we've divided by 2. And now that it's isolated, we can set up our 2 equations. So my 2 equations that need to be set up, we're going to have z plus 3 less than or equal to 12 is going to give me my first answer if we solve for z. And my other side, we're going to have z plus 3 greater than or equal to -12. We need to flip the sign and make it negative because absolute value, as I said before, we're going to have 2 answers for it. So that will give you both of your answers. So you're going to have 2 answers for z. So go ahead and solve both of those equations for your answers. Next one says Ms. Hernandez needs to buy at least, I want you to underline the word at least, because if we're buying at least 40 candy bars, we want to have at least 40 or more than that. So we know that the Candy Hut charges 75 cents per Hershey bar and 50 cents per Milky Way. Set up a system of 2 equations and solve for a combination of Hershey bars and Milky Ways. What we should always do first here is identify what your variables are. So if we know that we have an x and a y, we can say that our x is going to be our Hershey bars and our y is going to be our Milky Ways. Milky Way. And so if Ms. Hernandez goes to Candy Hut and purchases at least 40 bars, we know that x and y are my candy bars, and if we need at least 40 of them in order to make our first equation, we can say x plus y, which is our total number of candy bars, must be greater than or equal to 40. And the way that I got this sign is because if we see the word at least, we know that this amount, my total number of candy bars, needs to be at minimum 40. And for my second equation, if it says 75 cents per Hershey bar, we know that my x values are going to be 75 cents each. And for my y, it says 50 cents per Milky Way, so we can say plus 0.50 y. I know that's hard to see, I'm sorry. And it needs to be $28. So it says she can purchase with $28. So this amount must be less than or equal to 28. And the way that we got the less than or equal to sign is because this amount has to be less than $28. She doesn't have more than $28 to spend, and you can set up and solve it from there. Number 3, with absolute value, again, you've got a couple ways you can do this. Either number 1, you can just graph it and then sketch, or the second way, you can solve it. We'll say or not solve it, I'm sorry, or use transformations. Ran out of room, use transformations. So if you remember what your regular absolute value is, just my absolute value of x is going to look like this dotted line right here. And so if you remember your transformations, if you have something that has a -5, it's going to be going down 5. And if you have +2 on the inside, it's going to go left 2. Anything that's on the outside like the 5 is going to go up and down. If it's on the inside, it moves it left and right. So if we want to graph x plus 2 minus 5, we're going to take this original purple parent function, we're going to drop it down 5 spaces, so we're going to go 1, 2, 3, 4, 5, and then we're going to go left 2, so after I go down 5, we're going to go 1, 2 to the left. So my new equation is going to be right here. So the red equation would be our answer because we went 5 down and left 2. For number 4, with the inverse, we haven't done this in a while, but if you remember your steps for inverses, step 1, we need to replace f of x with y. Remember, f of x is the same thing as y, so whenever we rewrite this, this f of x is now going to become a y equals 3x minus 11. Step 2, we need to switch your x and your y variables. That's what makes it an inverse. It's like an evil twin opposite. So if we switch x and y over here in our equation, now we're going to have x equals 3y minus 11. And your very last step, now we need to get y by itself. So we need to solve it for y equals. So think about how you would solve this equation over here, but we want to get y by itself. So think about how we would move the minus 11 to the other side, and then what we would do with the 3, and that will give you your answer. And it will say y equals whatever your inverse is. Number 5, it says the sum of two integers is 18. If you think of the word sum, we know sum means addition. And if we have two integers, we can just call them x and y. So the sum of two integers, x plus y means sum, is 18. So x plus y equals 18 because the sum of two integers is 18. So that's where we got the equal sign from. The next part's a little trickier. If you see 2 times the smaller integer, well, we'll go ahead and just call the smaller integer x. So if we see 2 times the smaller integer, 2 times means 2x. And then if we say, is 9 less than the larger integer? This gets tricky because if you see is, we can make that an equal sign. So 2 times the smaller integer is 9 less than the larger integer. So if I have my larger integer y, and if you think about how you'd write 9 less, we can just say minus 9. And then if we want to solve this system, you can graph that in your calculator and solve it, and you'll see where the points intersect, and that will give you your answer. So on your graph it, find your intersection point, and it's going to be an x comma y, and that'll be your answer right there. So that's what you're looking for. Next one, simplify. We got complex numbers here. So if they're touching with no sign between them, we know it's going to be distributive property. So the first thing I can do is I'll multiply negative 4i times 3, and then I can do negative 4i times 2i, and then I'm going to have my 8 times 3 and my 8 times 2i. So you're going to end up with all your terms, and then we have to simplify after that. For number 7, if we have our inverses, let's say that we have our f right here, and then we have my f inverse. That's why it says f negative 1 means f inverse. It says they reflect over a certain line, so I want you to find in your notes what the equation of that line is that they reflect over. You can also think y equals mx plus b. That will probably help you find that equation of the line. But the equation we write it as y equals something is what we're looking for. Number 8. What is the solution set? A couple ways we can do these. If you want to graph it, you can graph it. But if you want to solve it, we need to isolate our absolute value first. So this part's already isolated, so what I can do now is set up my two equations. I'd have x plus y equals 13. And just like with what we did on number 1, it's similar to that, but instead of having inequalities, it has an equal sign. So we can say x plus 5 equals 13 and x plus 5 equals negative 13, and you'll be able to get two x values as your answer. Next one, solution to the system of equations below. If you want to do this in your calculator, in order to do a system, so you can do these by hand, but on your calculator, on calculator, your steps are pretty easy. I'm going to go through them on the calculator, but I'll write them down here first. You want to go to do your menu, and then you want to do algebra, and then you're going to do number 2, solve for systems. Solve system. So if you want to plug in this system here on your calculator, what it would look like, I'll start over fresh. You have, open up a new calculator, and then we're going to press menu, and then you go down to algebra. We're going to go to solve systems of linear equations. And so this is where we see how many variables we have. So if you look at your problem, we've got 3 of them. We have x, y, and z. So in your calculator, what you're going to need to do is set it up with 3 variables, and then we're going to need to call them x, y, and z. And so then as soon as you click OK, you're going to be able to set up your equations. So you can type them in just like how they look on your review, and then we'll get our answer for x, y, and z. So we should get x equals, y equals, and z equals. Same exact thing for number 10. So see your steps for number 9. So look at 9. That will help you with number 10. Number 11, it says a golfer hits a chip shot over some trees. If the ball is hit off the ground and the path can be represented by the equation negative 0.8x squared plus 22x. And the important part is your units. It says y is the height of the ball in feet and x is the horizontal distance in feet. So they're both in feet. So we got to know which one the question's asking about. So if it says y is the height, I'm going to go ahead and just put height up here. And it says x is your distance. I'll do it in green. X is going to be your distance. So you're going to graph that equation on your calculator, and it's going to give you a shape that you might have to zoom in or out to see, but it's going to look something like the top of a parabola, just like if a golf ball was hit. And so think about what the question's asking. It says, what's the maximum height the ball reaches, and what's the max distance? So look at your graph and see where your maximum height would be, and then see where your maximum distance would be, and that's going to tell you exactly what you need to know. Number 12, solutions to a system. You can do this two ways. You can graph these. So you can do it one way. You can graph and find the intersection. My handwriting looks good today. Or option 2, you can do solving with systems. So just like how we did in the calculator before, you can solve it as a system, but instead of doing it as 3 variables, what you can do is you can solve it as 2. So if I want to do that, I can do the same buttons. I can do menu, algebra 2, and then I can set up with 2 equations and 2 variables instead. Number 13, we're going to go over this one in class because we haven't really talked about linear regressions, so just save that one for class time and we'll talk about it. Number 14, actually I can show you all 13. 13 in your calculator, if you forgot how to do regressions, we want to set it up in a lists and spreadsheets. You'll have to go to lists and spreadsheets. Then we're going to title our A column is going to be X and our B column is going to be Y. So then you're going to go through and you're going to list all your X's here. So we have 0, 2, 4, 6, 7, 8, 9. So you're going to put your 0, 2, 4 and all those, and you're going to put your Y's in there. And then after you fill up your whole table, we're going to move over to the C column and then do menu, statistics, stat calculations, linear regression. And so in this column is where you're going to put your X up top, you're going to put your Y on the bottom, and then after that you can just scroll all the way down to OK, and it will give you an answer. But I didn't fill in all the values, so it's not going to give me an answer. But that's how you do it on your calculator. Number 14, it says it can be transformed into vertex form in order to identify the vertex. We don't have to transform it into vertex form since we have our lovely calculators. So what you can do is you can graph this, and whenever you graph it, you're going to get a parabola shape. I'm not saying that this is your graph, this is an example. But remember, your vertex is that point. It's either the highest point or the lowest point on your parabola, and that's what we want. So you just need to graph that equation and see where your vertex is at. So your answer should be in an X, Y format. Complex solutions. If you see complex solutions, you should know that we're going to have an ugly answer here, so we probably need to do the quadratic formula. If you forgot what the formula is, you can always remember. A negative boy couldn't decide if he wanted to go to a radical party. Being square, he didn't go and missed out on 4 awesome chicks. The party was over at 2 a.m. So think about what your A, B, and C are here. Your A is whatever's in front of your x squared, and we know there's a 1 there, so we can say A equals 1. Your B is whatever's in front of your x, so we got B equals 3. And then we have C equals 3. That's your last thing there. So you need to take your A, B, and C and plug them into our formula to get an answer. Number 16, solution. You can graph these. You can solve them by hand. The easiest way to do these is if you graph them. So in my calculator, x squared plus 2x greater than 15. If I open up a new graph, I'm going to have to graph this as a relation. So if I delete that, do number 6, and then I can do x squared plus 2x is greater than 15. And your graph gives you your solutions, because if you remember, your solution is in the shaded area, so think about how you would write your answer using that shaded area there, and that will help you with your answer. Number 17, similar to one that we've done before. So for 17, if you want to look back at number numbers. 3. It's very similar to number 3. Your parent function is that purple equation. So on 17, if our parent function is the absolute value of x and we start right here, think about how much we move down and how much we move to the right, and that's going to be your new answer, because whenever you move down several spaces, that's what's going to go on the outside here, so it's either going to be plus or minus a number. And then whenever you move left or right, that's what's going to go on the inside. So I'm not going to give you too many hints on this one because it's very similar to 3. So if you're stuck on that, go back to number 3 and look at how we did that, and your answer is going to be similar. Moving right along, number 18. We just took a test on this, so I shouldn't really have to go through that. Just make sure you don't multiply these. They're not being distributed. It's just adding. So we're just adding those terms together and then combining them. Number 19, if Dwayne's driving at a constant rate of 50 miles per hour, that's going to be important. The distance he travels is a function of time. Makes sense. The longer he drives, the farther he's going to go. So if he drives for at most 7 hours, so the word at most is key there, then what would be a reasonable domain and range to describe the situation? So what we need to know is domain and range. If you remember, domain is x and range is y. In your case here, your x value is like your time, because that's your independent variable. And the dependent, your y, would be your distance. So if it says, what is a reasonable domain? So think about how long he's driving for. If it says he drives for at most 7 hours, our domain can go from 0 all the way up to 7. So this is basically saying that Dwayne can either drive for 0 hours, he can drive for 7 hours, but he can't drive any less or any more than that. And for your distance, you're going to need to multiply this, because if he doesn't drive at all, he's going to go 0 miles. But you're going to need to see how far he can go if he drives for 7 hours, and that'll give you the last part of your answer. Number 20 is very similar to number 11. So just like how you graphed 11 and talked about your x and y axis there, you're going to do a very similar thing with number 20. So the most important thing is always your units. So on your graph, your y-axis and your x-axis, make sure we label it. It says y is height in feet and x is time in seconds. So make sure you label those, and that will help you answer your question. Number 21, sketch the graph of the equation. You can do this by hand if you think about your parent function. Remember, our parent function for absolute value is like this purple one. And then think about your transformations. Think about what the plus 1 does to it. Does it move it up, down, left, or right? And think about what the plus 3 does to it, up, down, left, or right. What you could also do if you want to take the easy road is you can graph this in your calculator and you can sketch it. That's your choice. Number 22, if we want to solve another absolute value problem, we've done a couple like this already, so please go back and look at number 8. This one is very similar to number 8, how we solved it and set up 2 equations there. So 22 is just like 8. Look at 8. 23. We did these the other day in class. We talked about solutions are where your shaded areas overlap. So what you need to do is you need to graph both of these on your calculator. And then remember, solutions are where shaded areas overlap. So what you're going to need to do is look on your graph and see where your shaded areas overlap, and then you can have your solutions in there. So we can do x comma y. We can do 2 examples. So find 2 coordinate pairs in the overlapping shaded areas, and that will give you your solutions. Oh, I did it on another page. Anyways, that is all for the review. I know this is a long video. Please pause it when you need to. If you have any questions, please ask. Good luck on your finals.